Happy Friday, math scholars. Who's excited for the weekend? So here's what I just told my students. We're doing 1.7 today, which means the quiz over 1.4 to 1.7 is coming next Tuesday. You're going to want to come to a study party if you're available after school Tuesday or after school Monday or before school Tuesday. All right, this is called a function machine. You don't need to write it down. It's just a fun little illustration to talk about how functions work. Basically, functions have inputs, where you take a number and you put it in for x right about here, and then what the function would do is output the solution. The solution would be 5. So let's try another one. If I had an input of -2, what would the output be? What is -2 plus 2? Jose?
0.
Perfect.
Math.
No more math flirting. Okay. What if I would put a -10 as my input in my function? What would my output be? Caspian?
-8.
Perfect. So yeah, what comes in must come out. The input is called domain. The output is called range. We'll be writing that down shortly, I think. Oh yeah, right here. Go ahead and write it down. Your input is called the domain. It's the x values, also called the independent variables. I just move my boxes around all day long. And then my output is my y values, also called my range, and they're called my dependent variable. Now, something to get used to is they use function notation a lot in this textbook, and I don't know if that's something you saw last year. It's called f of x. I would read this f of x equals x plus 5. But the whole f of x is the same exact thing as if I would have just written y equals. Did you guys see that last year ever or not? I was thinking probably not. Oh, Roman's saying yes, so that's good. All right, a function, this is kind of key. A function will pair each input with exactly one output. So I'm going to show you examples of something that is a function, yes, and then I'll give you an example of something that's not a function, no. Okay, so let's say my input is 2, my output is 7, my input is 3, my output is 9, my input is 4, my output is 11, my input is 1, my output is 5. I'm just making up numbers.
Do we need to write this down?
You need to write the concept down, so I'll tell you the concept in a second. So the concept is every time you see an x value, it can only pair with one y value. So see how this 3 is paired with the 9, 4 is paired with the 11, that's great. Everything's great here. I'll show you something that is not so great. Let's say you have 2 paired with 7, 3 paired with 12, 4 paired with, I'm looking for a pattern, add 5, 17, and then 2 is paired with 9. So here's what went wrong here. I see 2 paired with 7, I see 3 paired with 12, everything's going great, until I see 2 paired with 9. That ruined it. You cannot have your x value paired with multiple y values, okay? It just isn't good. If you see that happen, you don't have a function. Okay, yes?
So this isn't a Centerpiece, huh?
Right, so if I would erase this one out, I'd be back and be like, okay, I've got a function. Now, something I should say, let me give you one more yes example. Let's say I've got 3, 4, 5, 6, 7 for my x values, and I've got 2, 2, 2, 2, 2. That's fine. Your y values can repeat all day. It's your x values that cannot be paired with more than one output. So it's the x's that can't repeat. You learned it last year. Perfect. And my 8th grade teacher said something funny. I don't know. You guys will probably giggle, but she always said, think of x's as girls and y as boys. Girls can only have one boyfriend. Boys doesn't matter, but it's the girls that can only have the one boyfriend. So you don't want 2 to be having the 7 as boyfriend and then 2 to have the 9 as boyfriend. I knew you'd giggle, but back in 1995, that's how my teacher explained it. Okay? All right, so you don't need to write these down. I just want you doing silent thumbs up or silent thumbs down if you think it's a function or if you think it's not a function. Okay? Okay, so do you think this is a function or not? I'm tricking you. I was tricking you. It's just like repeating entries. If 2 is partnered with 7 and 2 is partnered with 7, it's still partnered with 7. I just tricked you. So it's a partner.
You cheated.
Yeah, I cheated. I was tricking you, see if you were paying attention. So it's a function. It's fine.
No, I don't.
Alright, what do you think about this? Is it a function?
I don't know anymore.
You just want to look down your x values and make sure they're only partnered with one y value. So 2 is partnered with 7, 3 is partnered with 8, 2 is partnered with 7 again, that's okay. 3 is partnered with 8 again, that's okay. Everything was okay. And then this is obviously okay because there's no x's that even repeat once. You don't even know anymore. I do trick people to make their brains think. Okay, identify the domain and range of the following, then tell whether it's a function. So we got 3 partnered with 8, 6 partnered with 7, 9 partnered with 4, and 12 partnered with 3. So it is a function. I heard somebody say it. Yeah.
Why do they have to crisscross?
I don't know why they didn't just make this in chart form. If that's bothering you, that's not in chart form. It's kind of bothering me, I'll be honest. I could write like this: 3 partners with 8, 6 partners with 7, 9 partners with 4, and 12 partners with 3. So it is a function. What would be the domain? Domain is all the x values. So it'd be 3, 6, 9, and 12. I'm just going to list them. And then the range? And you like to go in numerical order. So 3, 4, 7, and 8. And then yes, it's a function. All right, same prompt. Yes or no? Are we looking at a function? No. And if you're not looking at a function, don't even bother listing out the domain and range. It's not a function. You know who ruined it, right? The 3. It can't be partnered with 1 and partnered with 4. Yes or no, is this a function?
No.
It actually is. You're only looking down the x values, and there's no x values that are repeating, so it is a function. So let's list out that domain, which is the x values. 10, 11, 12, and 13. And then let's list out our range, all our y values. 3, 6, and 9. And I wouldn't list the 9 twice. That's your range. All right. Make a table for the function and use the domain that is given. Okay, I would write this one down. This is a great example problem. So you have an equation, and this equation is going to generate the chart for you. They are telling you what the domain is that they want to go on the chart, and again, domain is x values. So we want the x values of 4, 5, 9, and 10. Now, do you guys remember from last year how to fill out charts? Is this something that you did? Don't remember? People forgot? Okay, so it's very easy. You just go one at a time, putting the numbers in for x. So what is 4 times 4 plus 3? Good job. That's how you fill out a chart. Then you put the 5 in for x. What is 4 times 5?
23.
Plus 3. 23.
I thought you said 23.
Oh, And then 4 times 9 plus 3. 39. 10 times 4 plus 3. And normally, if it's coming from an equation, actually all the time, if it's coming from an equation, it will be a function. Because it's not like you're going to put the 5 in later and get a different answer back out. That doesn't make sense. So if it's generating itself from an equation like this, it's going to be a function for you. Okay. So any questions filling out tables? Did that all come back to you if you forgot it over the summer? No? Okay. Still writing, or are we ready? Ready? All right, we're going to do another one just like this. Yeah, the domain given is in order. If this was out of order, that'd be really weird to me, so I would put it in numerical order down my chart, but it is in numerical order, smallest to largest, so that's good. Well, you might need a calculator. These numbers are getting a little bigger, and there's negatives involved. So you're allowed to use a calculator if you want. Dig those calculators out of your book bags, take the lids off, or just use mental math. That's cool too. I'll do my work over here. What's negative 2 times negative 2 minus 7? That's a lot of negatives. I think that would be positive 4 minus 7. You guys get negative 3? Something like that. Negative 2 times 0 minus 7. What would that one be? Negative 7. Uh-huh. Negative 2 times 3 minus 7. Negative 6 minus 7. No, negative 13.
Oh, I saw it.
And then this one's getting big. Negative 2 times 22 minus 7. So negative 44 minus 7. I heard Kenneth say it, negative 51. Alright, it's an error test problem. If I haven't told you yet, you take that on the computer. So you would be clicking the answer, and it's selecting all. So oftentimes we will be selecting more than one. It says Jerome is constructing a table of values that satisfies the definition of a function. What numbers could be placed in the empty cell so that the table of values would satisfy the definition of a function? So let's just go one at a time. Could I put a negative 5 here and have it still be a function?
Yeah, sure.
Okay. Could I put a negative 1 up here? No, because then the negative 1 would be partnered with a 5 and a 13, so no way. What about a 0? Because 0 is already here. What about a 2? A 2 would be okay because I don't see 2 up in the input column. What about 11?
No.
And a 17?
Wait.
So I think it's only those two. Okay, there's a lot of those. We just select multiple answers. So select all means select multiple answers. Oh, another error test. Complete the table. Oh, complete the first table so that f of x is a function. Complete the second table so f of x is not, or g of x is not a function. All right. So raise your hand if you want to help me on this first one. We can pick any numbers in the world. Anthony's going to help me out. What do you want to go here?
3.
Sure. What do you want to go here? Sure. What do you want to go here? Sure. That he did great. That would be a function. I'll stick with you because you're always a math scholar. Complete this table so it's not a function. What do you want to go here?
Nope.
It could be any number in the world, actually.
Oh, 3.
And then here?
6.
Now, if you want this to not be a function, Anthony has to either put a 6 here or a negative 1. So he did excellent putting the 6 there. And then here?
Negative. No.
You had to
3.
yeah, very good. Here, it could be any number so that 6 is partnered with 2 people. Okay, so it can't be a negative 8, but it could be any other number in the world. So that's how they're grading it. They're making sure they're having a repeating value in the x column. So very good job. I like that question a lot. It'll be a great test question. And a word problem. I think that might be about it. Well, we'll see. We'll see what we all left. A couple more word problems, and then we're done. You're buying tickets to a football game that costs $30 each. Yeah, well, not if it's a Browns game. That's cheap if it's a Browns game. You can buy up to 8 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. Identify the independent and dependent variables, and identify the domain and range. So I always like just using x and y. Let's have y be like the total cost of the whole entire tickets you're buying. And let's let x be how many tickets you're buying. What would the equation be that would like generate this function for me? If they're $30 each, and I'm buying an x number, it'd be 30 times x, right? So just to show you how I could make my chart. 1 ticket would cost how much? 30. 2 tickets would cost how much? 3 tickets. So you kind of get how that works. And then 8 tickets would cost how much? $240. Okay. So that's how kind of that works. The independent variables would be X, and that's number of tickets purchased. The dependent variable would be Y, and that's the cost, the total cost of purchasing tickets. Does that one make sense? The football problem. All right. How about the centerpiece problem? A florist is making centerpieces for a charity event. She's using 9 flowers in each centerpiece. Write a rule for the total number of flowers used as a function of the number of centerpieces created. So I would probably do another chart type thing here. If she makes 1 centerpiece, how many flowers would she use? If she made 2 centerpieces, how many flowers would she use? So you're kind of seeing how this pattern would develop. What about 3? So to write it as equation, y would be what times what? 9 times x. I heard somebody say it works that. 9 times x. Because if you make 3 centerpieces, you do 9 times 3. If you make 5 centerpieces, you do 9 times 5. Okay? So this equation would generate this table. Okay. And let's have this be the last one. You are joining a kickboxing class at a local gym. The cost is $5 per class. So that's going to be 5x plus $25 for the initial membership fee. Write a rule for the total cost of the class. Just did it. How much would it cost if you went to 8 classes? Might need a calculator for that one. We want the cost of going to 8 classes. Or maybe you could use your head. Yeah, you could do your head in your head. What is 5 times 8? 40. 40 plus 25? $65. So you have your initial fee and then 5 per class. Does that equation make sense? All right. We'll go call it a day here, get our band member down to band. What you want to do is either do this off the online book or look under Polaris. If you do go into Polaris, you're looking for 1-7 is the section. All right. Thanks for watching the video.